Hello and welcome to the TMC Newsroom. Thanks for watching. My name is Rich Tehrani. Today we are at Interop New York 2010. It's October in the nice Jacob Javits Center. It's a nice crisp day outside, and on our program is Devin Akin, who's a chief Wi-Fi architect, and he works for Aerohive. How are you?
Doing well. Thanks for having me here.
So what does your company do?
Aerohive is a next-generation Wi-Fi infrastructure platform. We're a controllerless vendor, which means our access points talk to each other, have a protocol we call cooperative control, where they talk to each other to handle all of the control plane functions.
Sounds very meshy.
There's native mesh. Yes, it's mesh by default, but it's an access platform. It competes with the Ciscos and Arubas of the world. We specialize on not just a controllerless, but being feature-rich platform, easy to manage, being low cost in the market, and so especially in distributed deployments, very low cost solution. But it's a very competitive market. So we found the 802.11n transition has allowed us a chance to jump in and be very, very competitive.
So I've heard from other vendors, especially Xeros, they say that the future is going to be all WAN. Or not WAN, I'm sorry, all wireless and no wired connections in an organization. Do you feel that's the case?
No, I don't.
Interesting.
I think wired will always have its place. Wired will always have speed advantages, and it's not a non-shared medium. I think that wired is going to certainly always be there in the data center, even out to the edge, at the edge switch. But when it comes to access layer or meshing or building-to-building bridging, yes, I think wireless will be the predominant player. I think it'll be the primary solution. In fact, I believe that we're going through that transition now. The primary access layer is already Wi-Fi, or in some cases 3G or 4G. Everybody's looking for that wireless connection, and then if they can't find it, they can't get access that way, then they go to the wire. So it's already there.
So what are customers telling you about your solutions?
They find it more scalable. They find it more cost-effective to deploy, especially if they want to grow linearly, start small and grow. They can do that. There's no controller tax, or you don't have to plan the scaling of your solution based on how big your controller is, the redundancy of a controller, or anything like that. You can simply scale your solution by adding more access points. So it makes it very cost-effective to deploy Wi-Fi. They look for mission-critical deployments. The architecture that we have, which is fully distributed, allows for mission-critical deployments, moving away from the convenience networking. So the solution it's shocking the growth rate of the company, I'll tell you that. So everybody has just loved and is oogling the solution. In fact, the industry itself is following our lead, is distributing, the controller-based solutions are now distributing intelligence to the edge.
So you were saying that it's lower cost. I would imagine that it would be more expensive because each access point has to have a controller in it, but I'm understanding as you're talking that Moore's Law is probably at the point right now where it's so inexpensive to just drop these inside an access point so that you have one less box to worry about and you spread the task over a number of access points. So you're shaking your head yes, right, or nodding yes? So
I think you explained it just about as well as it can be explained. The fully distributed architecture, the difference in the thin access point to a very intelligent access point in hardware is not that much. The processing differential is huge, but the cost of doing that is very low. The commodity hardware that you can get, CPUs and RAM these days, you can build an extremely powerful AP for very, very, a very small differential from a thin AP. And by doing that, you can eat the difference as a manufacturer, eat the difference between the cost of goods from a thin AP to an intelligent AP. But in so doing, you get the flexibility of deployment, you get more scalability, you get more intelligence at the edge, no single points of failure. You get, there's so many advantages in doing this, and it's Moore's Law that made that possible. Over the course of, from 2002 to now, where the 802.11ag world controllers were appropriate, they were scalable enough. But 802.11n is so much different. There's 8 times as much throughput to deal with. There's mission critical pieces to deal with. You need a completely different architecture to deal with that. And Moore's Law has allowed us to do that. You couldn't do that 8 years ago, but now you can have these massively powerful APs that are very low cost.
So this is a question that probably is not what you were expecting, and I'm not sure that, I'm curious about it, so I'm going to ask it. That's one of the prerogatives of an interviewer. Have you been following what's going on with Super Wi-Fi at all in the white spaces?
To some degree, you know, it's still a little ways off until we see the chipset manufacturers, the Atheros and the Marvells and the Broadcoms and these guys adopt this, build chipsets around this, and then push this into you know, access point manufacturers and so forth. It's not a real solution yet.
Okay. What's next for the company?
I'll tell you that, you know, we were founded in '06, shipping products in '07, and in this whole you know, 3.5 years of shipping product, we've been a fully distributed controllerless solution. That's where the market is trying to get to. It's where we've always been. So our question to ourselves is, what's next? The what's next is leveraging that distributed architecture. What can you do with the network is the computer, if you want to look at it that way. All these processors, all this RAM sitting out there. So what you can do with that is you can put services into the infrastructure, let's say Radius. We can build Radius into every AP and do, so that you can get rid of your Radius infrastructure, makes it more resilient. You can put applications over that infrastructure that you, just like you can't kill the architecture, you can't kill the application because it runs on the infrastructure.
Right.
TeacherView is a good example. We've launched a new application for the K-12 market that allows teachers as non-technical administrators to control their classrooms. To say you can go to the internet or you can't, or we know which URLs you're going to, or we can stop that. We can say these clients have this signal strength, or this one has a problem, and they can control and monitor that classroom as non-technical administrators, but all of it runs on the APs. All of the APs feed the graphical user interface, so if an AP dies, the next AP takes over. It's applications that are as resilient as the infrastructure.
So I think it was Scott McNeely at Sun who said the network is a computer, now it's the access point is a computer. Are you going to go on record with that one? I can let you have that.
So no, actually I believe it wasn't Scott McNeely. It was one of their chief scientists that said that, but he's right.
Being that I'm a CEO, you know, I know CEOs get credit for everything that's said in the organization.
Of course they do. So anything I say, our CEO will take credit for, and that's fine.
Meant respectfully, meant respectfully.
So
covering your
butt on that. I will say, is the network the computer? Yes, it is. You know, we are actively evaluating. You know, not only do we have a distributed architecture, distributed intelligence, but what if you could centralize the intelligence itself to be able to pull information from those infrastructures, correlate, and push that intelligence back out. So if you saw a problem in one vertical, you might can help another vertical before they ever knew there was a problem.
Makes a lot of sense too.
Yeah. So centralized intelligence with a distributed architecture that's so resilient that you can't kill it. So I call it Wi-Fi that won't die.
That's great.
So that's my little moniker.
And that's yours. That's not your CEO.
Mine. I made that up.
And you're on video right now.
That's right.
Video evidence here. That's great. Well, thanks for being on the program.
Thank you so much, Rich.
Have a good show.
Okay.